Hello everybody, welcome back to another episode in the Let's Mod series. And you may notice first off that there is a slight change to the file system. Now, I think I mentioned in the previous episode or something along those lines that I was recoding the entire mod or just rebuilding the entire mod from scratch because I made so many dumb mistakes setting up the previous setup, this one over here, that I just wanted to fix it all at once and not have to worry about it again. And I have been doing that. That's mainly why there haven't been any episodes out. I of course didn't do all the coding again. I sort of flipped things over into the new framework. But you may notice, like I said, some changes to the file system. And most notably, Startup Common is gone. That horrifying class that we spent most of our time in over here. Let's see, Java. Yeah, Startup Common down here is no longer in existence. And that's because it was a terrible, terrible idea. So instead, most of its functions are probably found over in, let's see, events, register blocks, probably. So instead of creating things in static initializers, I've moved over to the registry events, and you can see I've also moved away from the base class of the base item class and the base block class. So the reason I did that is because I didn't realize back then that what you could do instead is set up an external class like setup block, and this class runs basically the same methods as the base item and base block classes, except they don't prevent you from reusing that code if you want to extend a different subclass of item. Like for example, if you wanted to make food and all you had was item simple from my previous episodes, then you would have to you would have to duplicate all the code from item simple to make a new food simple item or something. And the way I've gotten around that, like I said, is I've got this class here which runs a bunch of setup methods on the object you pass it. So that's a much better way of doing things. And like I said, everything in the registry event instead of static initializers. And what I've moved to over there, if I want my references, if I want those variables, sorry, don't know why I clicked that. Yeah, AA blocks. So I'm using the object holder annotation from Forge, and this will basically inject values into these static final variables and get me all my references back. So that's all cool. Oh yeah, over in the proxy area, I have a client proxy and a server proxy and an iProxy interface. And that's the proper way of doing things instead of a client proxy, common proxy situation, which is not the way to do things. And if you want to see the proxy declaration right there, it's just this thing. Cited proxy, if you're unclear, injects one of these classes into the variable right here. And since both of them extend iProxy, that's fine. And they both have the same methods, but I can separate stuff from the client and the server. Another cool thing that I've done, although my implementation of it currently needs some work, the system itself is cool, just not the not what I've done with it so much. I'll explain that a little bit later, maybe, or in another episode. But I have tick handlers, and I've got a client one and a server one currently. Oh my goodness. Currently the client one and the server one are not client server specific. They're not they are not separated. See, over in here I have a tick handler server, tick handler client, both declared straight up in the artificing main class. Yeah, that needs some work. But the concepts themselves are cool. They're useful things. So basically I've got a sort of task list, a task array, and I want, if I want to run something in the future, some number of ticks in the future, that's what these classes do. So I can schedule a task and check through the scheduled tasks to see which one, if any, needs running. And it's all in an ordered system, so I only have to check the first one. I don't have to check every one. So if the first one isn't ready yet, then none of them are ready. and you can just forget about it. So it's pretty cool. I'll show you, like I said, I'll show you my implementation. I guess might as well do that now while I'm on the subject. So I've also done some crystal splitting, so not a lot of code duplication there. It's much slicker. I'll show you that in another minute. But yeah, my implementation of the tick task over here. So where is it? Goodness. All right, so I found it. It's been a while since I've looked through this code. I spent a long time just on my graphing calculator side project. However, you can see I have this tick task, yes. I have this tick task class, and I can create a new instance of that, feed it the number of ticks in the future that it should run when you create a new one, or sorry, not when you create a new one, when you run it, it should run this many ticks in the future. And so I've got this basic one up here, and when I first load the tile entity into the world, I initialize its task, which is a lambda, a functional interface, a runnable thing, sort of like a method, but not. And I initialize it to this thing, so update scheduler, feeding in the array of object parameters. So I can give it some any parameters I want. Just it has to be in the form of an array of objects. And then you just schedule it, and it'll run that many ticks into the future. Remember this number of ticks in the future. So that actually works really well. And I wanted to get around the fact that normally you would check every single tick to see if it was time to do something. You might set up a tick counter in every tile entity, and it would increment a value up to some other value, and then do something and reset and wait for it to reach the second value again. And that's not very efficient, running in every single tile entity in the whole world. So instead, what I've done here is set up a system where I can schedule this task to run some number of ticks in the future, and that puts it into our ordered array of tasks, and it will get run sometime in the future. So it's definitely a more efficient way of doing things, but I definitely also need to clean up my implementation of it a little bit, because it's not very server client friendly, and it's not very pause game friendly. That's again something for the future, but it's got its problems that I need to work out. But overall, it's a good boy. It's a good lad. Let's see, what else have I done? Yes, so I've actually used Java inheritance. That thing that sometimes exists in good code. So I've got a bunch of methods set up in my main class here, and this class doesn't actually ever get isn't ever directly used, so to speak. It's slightly abstract, but not quite. Maybe actually I might be able to change it to abstract and not have any problems. I'm not gonna do that though. Anyway, basically, I've set up a bunch of tasks. It handles the NBT data and all that good stuff for me. So a lot of basic functionality there, pre-set up. And then when I want to create a new crystal, all I have to do is this, and this is much cleaner. So there's a setup system, a setup method, in which I can give this crystal all its useful abilities, and then an update task in which I can do things that should run every update, and then not sure what this is actually. Goodness. Oh, right. Sorry, I opened the wrong. Okay. So let me try and find a simple one. Basically, that pipe, I was experimenting with stuff. I've got a 3D transformations library, and I was mucking around with stuff in that specific tile entity, testing things. Okay, this one should be simple. Yeah. So we've got the setup method, and we give it its base stat, which some other settings are derived from that, the base stat, and we give it the ability to hold energy, to push energy, we give it a range, and we tell it that it updates, that it connects to other things, all that good stuff, right? And set its RGB. And then on the update task, if the energy is not safe, it explodes. If it doesn't have redstone, it can move energy, and that's it. I've got these nice basic high-level commands that I can tell things to do with, tell stuff to do stuff with, so to speak. And in other implementations, it does get a little bit more complicated. Let's go with Crystal Breaker, but it's still pretty cool. It's still pretty nice. This is the block breaking machine, so you give it a bunch of blocks to break, a bunch of positions, and it'll break those positions. And in its update task, if energy not safe, explode. If not redstone, then break connected blocks. Pretty cool stuff. Alright, so a couple other changes. Now, we built this in the other episode, and you might notice it's got some fancy other stuffing. What am I even saying? It's got some bars over it. So that's a display of how much energy it has. And I believe, oh yeah, I changed how this works, didn't I? So yeah, a lot of stuff has changed, and I can't even work it myself. Let's see, alter block connections, tweak block connections. Tweak block settings, alter lattice tweak connection. Okay, so I think this is how it works. All right, let's add that. Yep, adding, and then let's alter block connections. Add that. Right. So now it connects over to here. If I toss that there, right. Awesome. So I do understand how it works then. And you can see that top bar is the fuel. It's a little crooked. Don't know why that is exactly. But there you go. Alright. Have a bunch. And yeah, I think things are working pretty well actually. I'm pretty pleased with this whole system. But yeah, the main change here is the bar over the top, which does also look pretty neat if I do say so myself. Let's see. Yep, that's my position library testing. So maybe I should not use these pipes. But yeah, a lot of things have been changed a little bit. For example, these you have to directly connect them to the other blocks. Actually, everything needs. Ouch. Yeah, so everything needs to be directly connected in order to function. It doesn't search an area around it, and that's mostly for performance issues. I mean, I want to make things as performant as possible, and searching a whole area every tick, or not every tick, but every time you want to move energy. Every time you want to move energy is expensive, so I don't want to try and do that. Yeah, go away. But yeah, a lot of little changes have occurred, and a couple bigger changes. I've actually managed to set up a GUI system. So if we open this, it's so cool. Let's see, a seemingly absent icon. So yeah, information about different things. This is on the invisible block that I put together. I haven't actually set up a video for it here. Example 3 and references, placeholder button. Yeah, so cool stuff. Cool stuff. Here are the blocks in question. Just an absence of texture, basically. And I think this is the solid, yeah, dark air. Blots out light. So, like I said, lots of cool different changes, but nothing unrecognizable. Most of it's just code optimization. On the NBT data front, because I do have a fair bit of that involved with all this data storage, I should probably switch over to capabilities. So if you're watching this for some reason, hoping to get tips, then go for capabilities. They're generally better and more approved of. But I've set up some NBT NBT handling classes to make my prancing into the unapproved section a little bit less ugly, because NBT data is it tends to be a bit sloppy, which is which is a good reason to use capabilities instead. And my NBT handlers do improve the situation a little bit, so I can get values simply without having to check for the presence of said value. There's a default system, and it works pretty well. But I should probably still switch over to capabilities anyway. So one more thing that I'll show off a little before ending the episode, and I'll probably end up using this in the artificial artificing coding as well, is I set up a sort of annotation event system for personal use as opposed to the one that's already in Forge, because if I want to trigger an event when something happens, I don't think I can do that with Forge events. I might be wrong, but I don't think so. Anyway, I've set up this system then. So you can see I've annotated all these methods with trigger on test, and over here I event.trigger test and pass it in some null parameters since none of these take parameters. And this is my timing system, by the way. So first it takes the nano time. It takes the nano time before doing a normal set of method calls 10 million times, and then it takes the time after that, and then it calls my event 10 million times, and then it takes the nano time after that, and it prints out some useful values that I'll explain in a second. But let's run that. And pop. There we go. Oh yeah, it's probably taking a little bit longer now that I'm recording, funnily enough. But anyway, we've got 94, 30,500, and 323. So this is the number of well, these two numbers are in 10,000ths of a second. So it took 94 10,000ths of a second in order to complete this block, and it took another 30,000 10,000ths of a second, or about 3 seconds, to run this block. And that means that my event system took 323 times longer than than normally calling a method in Java, which isn't awful, I don't think. I believe at one point I worked it out to be about 700 millionths of a second, or sorry, 700 millionths of a second to call one event to call one method with this event triggering system. So it's not awful. And the way it works, I'll show you right now. You spread the domain, you stretch the domain of my annotation handler. So the annotation handler will find annotations that you it'll find annotations of a type within a domain, and you have to tell it what domain to look through. And then with the event system, all I have to do is trigger an event with a string and pass in parameters. So let's demonstrate one here, just beyond this testing. So let's say I have a static method that returns a string, and let's see, eat cake, and I'll give it a string of type of cake, right? And then let's say if the type of cake is chocolate, then I can return yum. If the cake is strawberry, then I'll return yick. And let's just do that now. There we go. And I didn't I didn't do the strawberry thing because I didn't feel like it. So if it's chocolate, it says yum, else it says yick. And now we will have that trigger on an event that we're going to send out right here. So let's say event.trigger, and we will pass in eat cake. And we will give it no arguments. Or actually, so we do need to give it an argument, right? We need to say chocolate. That's the type of cake it's eating. Ha. And we can, the cool thing about this event system, by the way, is that it does give you the return values. So hold on. Returns equals, there we go. So returns is going to be an array of the returns that we get. Kind of funny that. Okay, I just decided that we'll step through it in the debugger and look at the contents. It's easier. Anyway, so now that we have our method here, we want it to trigger on this event here, and we'll gather the return values. So now we just annotate it with trigger on eat cake. There we go. And now if we run this thing, let's run it in debug. Pow. Returns. Yum. There we go. Very nice. And as you can see, we have yum in our return list. Very nice, very nice. So now if we if we pass in not chocolate, that's probably how you spell chocolate. And then we run that, we have yeah in our returns list, which is pretty much exactly what we wanted. Alright, now of course, this being an event system, we can have multiple different what am I trying to say? Different methods that trigger. So I can trigger on the same eat cake and different method though, and in fact different return type. What do I want to return? Uh-oh, I should have thought of this. Let's just say int. Okay. Not eat cake called. Because it doesn't have to be called something similar, right? It does have to take the same number of the same parameters though. So type of cake. And we can just return 5 because I don't care. There we go. And let's debug again. Returns. We have yeh and 5 in our returns list. So that's the long and short of the event system. I'm pretty pleased with it, especially since it doesn't search through all the methods every time it needs to run. It keeps them stored in a hash map, and if the oh, what am I trying to say? if the domain changes, only then does it research. So it only researches when it needs to. So pretty cool stuff. However, I think that's all I have to catch you up on today. Hopefully next episode we can do something interesting. And I will see you in the next one. Take care, and bye-bye.